solve logarithms to rewrite expressions with no log term with a product, quotient, power, root. So this is expanding logarithms, and it is an important school. This is probably, of all the things that we do with logarithms, this is the one that students somehow have trouble with. But it is important, especially if you're going to go on to calculus, applied calculus next semester. Doing the calculus of logarithms is much easier in the expanded form than it is in this compressed or condensed form. Alright, so it is an important skill to do. So the first one, I have the natural log. And I did natural log base 10 because those are your common logs, but the same would be true for any base. These are just the easier ones to draw out. So again, the way this works is the same way for all bases. I just chose to do the two common ones. So the first thing is, again, you have to follow order of operations. So the first thing I want to do is I want to get rid of the division. Alright, well, I get rid of the division using the division rule for logarithms. I split the division inside the log by subtracting. And so it's going to be the natural log of the square root of x minus the natural log of y cubed. Alright, so that's equivalent, right? I can divide the fraction, I can split the fraction into the subtraction. My next step is going to be to get rid of the powers. Well, the square root I'm going to rewrite, natural log of x to the 1/2. And so now I'm going to use my power rule. I'm going to pull my powers out front. And so it's equal to 1/2 times the natural log of x minus 3 times the natural log of y. And now I've got it written as a simple log where there's no product, no quotient, no power, and no root inside. And it is equal to the original. If you graphed those two functions, either the condensed form or the uncondensed form, they'd be exactly the same. Alright, next example. Log base 10, but again, would be true if it was any base. So I've got log base 10 of x squared divided by y to the 4th, square root of y. Okay. So the first thing I do is, again, I get rid of the big fraction. So I rewrite this as the log of the numerator, which is x squared, minus the log of the denominator, which would be y to the 4th times. And I'm going to go ahead and change the root function to x minus 1 to the 1/2. It's up to you. You can do that later. Eventually we're going to have to do that. I just like to do it right away so I don't forget. Alright, my next step is to get rid of the product. So this log stays the same, x squared. Make sure you're careful that minus is outside. I'm going to have to remember to distribute it in a little bit. So I'm going to put brackets or parentheses around the log of y to the 4th times, so let's add, the log of x minus 1 to the 1/2 power. Again, that was all divided by it, so when I have the minus needs to be all of that expression. So either you leave the minus out front or you distribute it. I'm going to leave it out front for now. My last step is to move the powers out to the front of each of my logs. So it's going to be 2 times the log of x minus, in brackets, 4 times the log of y plus 1/2 times the log of x minus 1. Try to write that a little neater. So 4 times the log of y plus 1/2 times the log of x minus 1. And I'm really done at this point. I no longer have a quotient, a product, or roots. You cannot simplify that expression log x minus 1. You cannot distribute the logarithm. It's one of those false statements that I gave in the previous example. Log of x minus 1 is as simplified as it gets. The only thing you could do if you wanted to would be distributing the negative, but I actually think it's easy to leave it, so I'm actually going to leave it. And so there is my expression completely expanded, which equals my original. Alright, that expression, 2 log of x minus, brackets, 4 log of y plus 1/2 log of x minus 1 is where it's completely expanded. I can't do anything more. I've got no products, no quotients, and no powers, and no roots. Alright, next example. This one's a lot like the first. Alright, so the first thing again we do is get rid of the fractions, so it's the natural log of k times x to the 6th minus the natural log of 5. So I can split the k and the natural log, k and the x to the 6th into the natural log of k plus the natural log of x to the 6th. Still minus the natural log of 5, and the only power I have is the 6, so that's the last thing I do, so it's the natural log of k plus 6 times the natural log of x minus the natural log of 5, and there I'm done. I can't go any further than that. And there's my expression completely expressed with no powers, no quotients, no roots. So again, that's as expanded as it gets. All right, the last one. Alright, so first thing I'm going to do is rewrite my natural log is log. Rewrite my root as a power. Make sure I didn't miss anything. Alright, so I rewrote that square root as, so this would be the function that has the square root under it. So the 1/2 is that root of 2x to the 5th times x2 minus x. Alright, so the first thing I'm going to actually do is pull my power out this time. So I'm going to get 1/2 times the log of 2x to the 5th times 2 minus. I've got to remember that 1/2 is multiplied by everybody anything that I do after this point is multiplied by the half, because everything was under the root. So everything is multiplied by a half. Alright, so when I go to my expanding, I've got to remember, so I put brackets because everything that I'm going to do from this point, make sure it's always multiplied by the half. So my next step is to get rid of the times. And so I'm going to rewrite this as the log of 2x to the 5th plus the log of 2 minus x. All still times a half, so that's what that bracket stands for. And then I can split the 2x to the 5th, so I still have my 1/2 out front, brackets. It's going to be log of 2 plus the log of x to the 5th, still plus the log of 2 minus x, and then move the 5 out. So 1/2 times the log of 2 plus 5 times the log of x plus the log of 2 minus x. All inside the brackets. That 1/2 is, and if I wanted to, I could distribute the one. You could leave it like this, or you could distribute the 1/2. It's the same as saying the 1/2 log of 2, 5/2 log of x, 1/2 log of 2 minus x. And there's as simplified as she gets. Now those last two expressions are equivalent in simplification, so you could leave the 1/2 out front, or you could distribute it through. Again, they're exactly the same, it doesn't matter. But there's my completely expanded expression. I no longer have any roots, I no longer have any quotients, I no longer have any division or multiplication. I cannot simplify any further than that. That's as expanded as I get. Alright, there's my thing completely expanded. We're going to compress. So, like I said, the expansion is more of something that we wanted to practice. This is more going to be more useful if you are going on to Math 135 Applied Calculus in the next semester. When you do the calculus, you're going to want to expand your logarithms. Right? It makes the calculus easier. What we'll probably use more of when we go to solve applications, what we're going to do in the next video is compress it to a single logarithm, which we'll get to in the next video.